So now module 2, which is SI units. So the first thing you need to know in this module is what are base units. So base units are the basic units of measurements that other units will be derived from, right? So for example, mass will always be in kilograms, length will always be in meters, time will always be in seconds, temperature would be Kelvin, and sometimes it's in degrees centigrades, but I'll tell you how to convert it later in the syllabus. And current is in amperes, which is short for A, short for M. Okay, so these are the basic units that you need to know. In all other units that you see, for example, the unit of force is Newton, will be derived from these basic units. So let's just move on to derived units. So look at this formula first. Force is equal to mass times acceleration. Don't worry if you don't know this formula, because this formula is ahead in the syllabus and you'll learn it soon. So let's just put the basic units here. So the basic unit of mass is, as we learned, kg, and the base units of acceleration is base units of acceleration would be meter per second square, right? Or simply put, meter per second square. And again, if you don't know the unit of acceleration, it's no worries, just believe me for now and you'll learn it later. So the base units of force would be kg meter per second square. But force, the force is derived, force is said to be in newtons, right? So Newton is a derived unit which consists of these basic units, right? So this is the idea of derived units. It is always a product or a quotient of base units, right? So it's a product of kg and meter, and the second square is quotient. So just remember that derived units are products or quotients of base units. So let's see one more example and then we'll move on. Now this is density, which is mass over volume. So the unit of mass is kg again, and the unit of volume is meter cube. Now the base unit of density is kg per meter cube. So these two examples I think will suffice on what derived units are. So let's move on. Now, prefixes. The first thing you need to know here is the standard form. Now, whenever you are giving your answer in prefixes, this is the form you are going to use to give your answers. Now, what is this form? The form basically says that it only has you're only supposed to use one figure ahead of the decimal point, and that becomes the standard form, and this n is a sum power of 10, right? So for example, if I write 0.35 multiplied by 10 power 3, this is not a standard form, right? This is not a standard form. But if I write the same thing like this, now this is a standard form, right? Because only one figure ahead of the decimal point, and there's a power of 10. So let's move on. Now the basic concept of prefixes is, please look at this table, and you need to memorize this table, these values as well, because in questions, sometimes they will give you the abbreviation, sometimes they'll give you a power of 10, and sometimes they'll even ask you to give an answer in terms of this abbreviation. So let's just go through the basic concept. For example, now we have a value 3 kilometers. Now, what this means is, how many meters would this be is, now let's just see this. Now, kilo is 10 raised to the power of 3. So it is 10 raised to the power of 3 meters. So what I want you to do is, from now on, in your calculations and in your mind as well, whenever there is this value, right, you have to look at this abbreviation and just consider it as a power of 10, which is its value, right? For example, for kilo, we took 10 raised to power 3. We can do another example. Milliseconds, right? Someone gives you 10 milliseconds. Now, again, we correspond it with the table 10 raised to power negative 3 seconds, right? So, to convert a non-standard unit into a standard unit, just add the abbreviation's corresponding power. Multiply the corresponding abbreviation's power, and you'll get it in standard units. And you can do this the other way around. For example, you have 3,500 meters, and now you can do this as 3.5 kilometers or 3.5 raised to 10 power of 3 meters, right? These two are same. And sometimes the question asks you to give your answer in kilometers, so you should do this, and I'll teach you how to do this. Now, giving your answer in other units, like we discussed before. So, for example, you have a value. Let's just take the other question we did before this one. 350 meters, so 3,500 meters, and you have to convert it into kilometers. Now, how do you go about this? So, the rule is whenever you move, first let me write it this way. Whenever you move to the right, all figures will move to the right. The power of 10 will gain 1. And whenever you move to the left, for example, whenever you move to the left, each value will move to the left. The power of 10 will be negative 1. You will minus 1 power from 10. So let's just discuss this. 3,500.0, right? Now we do 350. We moved everything one place to the right, 0.00, right? 10 raised to power 1. Again, 35, 10 raised to power of 2 because 0 right here. Again, 3.5 multiplied by 10 raised to the power of 3. Now let's do one example with a negative conversion. So let's just say 300 millimeter, 300 meter, 3 meter to 3 meter. Right? So now we have to convert 3 meter into 3 millimeter, right? Sorry about this. 3 meters to 3 millimeters. Now, what we need to do is have a power of 10 raised to the power of negative 3, right? Because this became 3.5 kilometer this way. We just turn this into a power of corresponding abbreviation. So let's do this one more time. So now we will now move this one place to the left, 10 negative, and basically subtract one number from the 10 value, right? From the power of 10. So let's do this. 30 times 10 negative 1. 300 times 10 negative 2. And finally, 3000 times 10 negative 3, right? So this became 3000 multiplied by 10 raised to power negative 3, or 3000 millimeters, right? Because that's the abbreviation that corresponds with the power. So let's do one last thing with this, which is conversion with squares, right? So what I want to do now is, for example, a reading of 100 meters. Now in centimeters, this would be 100 times 10 raised to the power of 2, which would become which will become 10,000, right? 10,000 centimeters. So 100 meters becomes 10,000 centimeters. Now, moving on, meter cube. Now, the way we deal with meter cube is, for example, a reading of 100 meter cubes into cm cube, cm square, I'm sorry, and a reading of 100 meter square into cm square. For example, the area of this rectangle is 100 meter square, but now you need to tell it in centimeter square. So basically that's the question. So let's just do this. Now what you'll do here is write your 100, write 10 raised to the power of 2 the same way, but what you'll do is raise this to the power, this power squared. So the answer would now be the answer would now be right. This would be the answer, 1 million. 1 million cm cubed. So you can see that conversion increases exponentially when you're taking area, volume, etc. Now let's do it one more time with meter cube so you'll understand it properly. Now I'm taking the reading of 10 because so the value doesn't increase too much. 10 raised to the power of 2 cubed, which becomes 10 million, right? 10 million cm cube. So this is how you convert to basically a squared value or a cubed value, because some of your formulas contains squared and cubes values, so you need to know how to convert it into standard units. Now this is here I'm not converting it to a standard unit, but in your exam you'll most probably be converting this to a standard unit, right? Now why did I take the value of cm square to be 10 raised to power of 2, right? Because to go from cm cube, right, to go from cm cube to meter cube, the power is 10 raised to power of -2. Or think about it this way, right? What is bigger, meter or centimeter? Which is bigger? The bigger value is meter. So 100 meters would result in a bigger value of cm, centimeter, right? So this is the easy way to do it. Otherwise, you can just do it the other way around with abbreviations and convert this power to different sign. Now, the last thing we'll do is going from one non-standard to another. Non-standard to another. And we'll use the same concept there as well. Now, you can look here. Let's just go from megameter to kilometer. Megameter to kilometer. Now, what you can do is think about it in two ways, right? For example, the first way was think about it if the value is going to increase or decrease. So obviously it's going to increase going from megameter to kilometer because kilometer is smaller, right? So 100 megameters would give us a larger value of 100 kilometers, or just subtract it like this. The power of 10 would go like 10 power of initial minus power of final unit, right? So for example, we have 100 megameters, right? 100 megameters. So its power is 10 raised to power of 6. So 100 in kilometers, it would be I'm sorry, 100 megameters, right? So in kilometers, it would be the power of megameter is 6 and the power of kilometers is 3. So it would be 100 times 10 raised to the power of 3 kilometer. And if you look at this, we did the same thing here. The power of meter is 10 raised to the power of 0, right? Because it's nothing. So anything raised to the power of 0 is 1. So the unit of basically the unit abbreviation of standard unit is 10 raised to power of 0, right? And this power of cm is -2. So what we did here is convert it from 0, -2, and it went to 10 raised to power of 2, right? So basically power of initial minus power of final. So that's what you do when you're going from one unit to another. And you can memorize this, or you can just use the idea that the value will increase. Whatever suits you best. I recommend both value. I recommend that you know how to do both, but whatever suits you best, right? So let's move on. Now, homogeneity. What is homogeneity in physical equations? So basically, every physical equation that you have will have the same base units on both sides, right? So the base units on one side of the equation would be the same as the base units on the other side of the equation. So let's just see this question as an example first. So this is the equation of speed of sound. So this is speed, this is pressure, the above value is pressure, and the denominator is gas density. And now we have to show that gamma has no units, right? So what we do is convert everything into its standard units. First, F is equal to under root gamma, because we don't know what the units of gamma are, so we just write it as gamma. Now pressure. Now look at, first we need to clarify this. Pressure is force into area. Now, as we discussed before, the unit of force is kg meter per second square, right? You can derive this again if you want, but I'm not going to waste more time. Kg meter second negative square, and the value of A is meter square. So whenever the value changes its position, the sign is multiplied by -1. So kg meter -1 second -2, and this is basically our pressure in standard units. So let's just write it here, -1 second -2. Now density, we did density as well. All right, density was kg per meter cube. So let's just write it here, kg meter -cube. Now the first thing you can do is just cancel out these kgs, and when this goes up here, it becomes positive because it gets multiplied by -1. So -3 times -1 is 3 gamma. Let me just write the full equation. Gamma times meter -1 second -2 multiplied by meter cube. Now this cancels out and this become -1, right? Meter per second is equal to under root gamma times meter square second negative square. Now what we can do is, because there's a whole power here, right? Power of -1, power of 1/2. We can just square this to cancel it. Square this. Now this square cancel out this, and this becomes meter second -2 is equal to gamma times meter square second -2, right? Because the under root just got cancelled. So now gamma is equal to meter square second negative 2 meter square second negative 2, right? Now all this cancels out, so gamma has no units, right? And that's basically it. So what you need to do, what you need to know about these equations is this module is the concept of homogeneity and just solving basic concepts, basic questions using this concept. The this thing, this formula, this is pretty important, right? Going from meter cube to centimeter cube, this is important. Knowing when to add the power of 10 and when to subtract from 10, power of 10, that's important. Standard form is obviously important because your answers will always be in standard form, and the basic concepts of base units and derived unit. And now we're done with this module.